Hi Ruby, hopefully this will help with those two questions. So the first one you did was this one here, where we've got to do implicit differentiation. So, which I've just written down here in blue. So remember what we have to do here. Whenever there's a y, we have to say dy dx. So the first term's fine, x squared becomes 2x. Now, because we've got the two variables here, we've got to use the product rule for the minus 2xy. Okay, so use minus 2x. V's y, so du dx is minus 2, and dv dx is dy dx. So u dv dx plus v du dx gives you this here, which simplifies to this bit in red. And then our third term on the left, 3y squared becomes 6y dy dx, and the differential of 50 is 0. Right, we then factorize and take everything with dy dx's, we'll keep them on the left and take anything without dy dx's over to the right, divide by the bracket and simplify, and we get what we needed. Right, for part B, well, you know when we do dy dx equaling 0, that gives us the maximum and minimum of our normal stationary points, so that would be here and here. Well, similarly, if you do dx dy equaling 0, it gives you the sort of the vertical points at P and Q. So just think of it as sort of shifting the graph quarter of the way around. So the key bit here, P is obviously a vertical asymptote. So that's, if you like, it's a stationary point to a degree. So that's got to be where dx dy equals 0. Similarly with Q, that would be dx dy equaling 0. Well, we know dy dx, so just flip that over and set that equal to 0. And therefore, the numerator has to be 0, 3y minus x equaling 0. So 3y equals x. At P and at Q, 3y equals x. So take that knowledge and substitute it back into the original equation. Gives us this, which simplifies down to 6y squared equaling 50, and y being plus or minus 5 root 3 over 3. Now we can see at P, the y coordinate is negative, so it's going to be the minus 5 root 3 over 3. And x is just 3 lots of the y coordinate, so that's minus 5 over root 3. Yeah, I've lost one of them. That's not quite right. The x coordinate should, the y coordinate, that's just fallen off when that should be 3 there, shouldn't it? The y coordinate's minus 5 root 3 over 3. Right, so your second question. Yeah, I thought part A here was quite tricky. I can see why this was a bit of a muddle. So y equals x to the power of x, and they give us the clue that we need to log both sides to start with. So ln y equals ln x to the power of x. And obviously power rule, the x comes to the front. Now we're going to have, for the stationary point, we're going to have to differentiate this and later on set it equal to 0. So we're going to differentiate both. And again, this is sort of implicit differentiation. Ln y, when we differentiate that, is going to be 1 over y dy dx, because it's got a y in it. Okay, so the differential of ln something is 1 over it. So that's 1 over the y. But because we're doing the y, that's 1 over y dy dx. So just be sure you're comfortable with the left-hand side. Now on the right-hand side, again, we've got two variables here. We're going to have to use the product rule, which I've done up here in red. So u is x, v is ln x. So du dx is 1, dv dx is 1 over x. Subbing in, we get 1 plus ln x. So then go and multiply both sides by y. We get this. And now we can go and replace the y with x to the power of x. So we've got this. And so there's our differential. And at the stationary point, this equals 0. So we set it equal to 0. Well, x to the power of x can never be 0. So this component can't be 0. So our bracket is going to have to equal 0. So 1 plus ln x is equaling 0. Ln x equals minus 1, so x equals e to the minus 1. Okay, so for part B, we've got this point alpha 2 lying on C. Okay, so we've got, subbing that in, we've got 2 equaling alpha to the power of alpha. Taking this all over to the right-hand side, we'll get alpha to the power of minus alpha take away 2 equaling 0. Now, if we go and sub in 1.5, we get a negative root. When we substitute in alpha being 1.6, we get a positive root. So because there is a change of sign, we can conclude that alpha is between 1.5 and 1.6. Now, part C, we're just subbing in to the iteration formula. So just to remind you how to do this, we're told that the first term is 1.5. So the second term is going to be 2 lots of 1.5 to the power of 1 minus 1.5. That gives us a solution. Then our next term is 2 lots of that to the power of 1 minus that, and so on. So our fourth term to 3 decimal places is 1.673. Now, for part D, sort of a little graph I think sort of helps. Rx1, Rx2, Rx3, Rx4. We can see that we're staying between 1 and 2, and you can kind of sort of feel that because 2 to the power of 0 is 1, 2 to the power of 1 is 2. So they're sort of our boundaries. And we're oscillating between these two, but we're not converging. We're not getting closer together. We're diverging. So hope that helps, Ruby. Have a good weekend. Bye.